In this video demonstration, we'll cover a tutorial of Trimble Access Monitoring using version 2021.00. First, we'll talk about what is Trimble Access Monitoring for. When we talk about deformation monitoring, there's two types of monitoring. There's campaign-based monitoring, which typically involves multiple visits to site, the sensor not being fixed on site, so therefore using a tripod. And we're typically looking for slow, imperceptible movement that's not high risk, and we're typically gathering low volume data sets. Automated monitoring, on the other hand, is where the sensor lives on site permanently and it's installed there, and this allows for real-time alarming and reporting, as well as detect time-sensitive movement, and typically generates large data sets that are hosted locally on the server or in a virtual server such as Microsoft Azure. Trimble Access for campaign monitoring streamlines the collection of total station rounds, reducing the operator input and field time for data collection for any of these manual campaign-based monitoring projects. This is done through round configuration and scheduling, scatter plot and displacement charts, threshold definition and warnings, and automatic and manual measurement modes. The Trimble Access monitoring workflow is broken into 5 steps. The first step is to define the station setup type, whether that's multiple backsites, single backsite, or resection. Next is to define the target monitoring points. These can be imported, keyed in, or measured while on site. This includes the target info, such as the target type and prisms and measurement mode. Next is to define the monitoring schedule. This can be a single epoch or it can be multiple epochs, where we can define infield warning tolerances and visualize those displacements in real time. Next is the ability to create real-time and infield reports showing all displacement information for the measured epochs. Finally, we can exchange data, whether that's through a JXL job file import-export or through a site setup transfer to T4D for automated monitoring. For additional data analysis, data can be imported into Trimble Business Center, where we can perform adjustments and QC on the data. As well, we can generate monitoring reports in time series using visualizing movement trends and alarm thresholds. Alternatively, we can export site setup information to the Setup M1 or T4D control for automated monitoring. Starting in Trimble Access, first we need to define our site. We'll connect to the total station, level our instrument, and enter any atmospheric corrections needed. Next, we'll define our station setup type and perform that. This can be a single backsite, it can be multiple backsites, or a resection. In this case, we'll use a single backsite. You can choose from imported or existing control points, or key in those control points while in the field to perform the site setup. For targets, you can define a custom prism type or choose from the existing prisms in the target type menu. Once this is all set up, turn the instrument to the location of the prism. If you're using an auto lock instrument, the instrument just needs to be pointed in the relative direction of that prism, and it will be able to find it and take the measurement. The first step to starting monitoring is adding monitoring targets. So we can go to the Add Point menu and we can measure our targets. You can also use existing points in your project. In this case, we're going to measure our monitoring points as our reference epoch. So I'll enter the target information and then I'll take the measurement for that point. Once that's been made, I can repeat this process for all new targets, defining the target height and then the measurement mode and prism type for each monitoring point. So you can have multiple monitoring points with different target types, measurement modes for all of them, providing flexibility on how you monitor your targets. Next, we're going to start monitoring. First, we'll go to the monitoring option in Trimble Access and we'll view the point list. Here you can see all of your measured targets, and we can review this list. We can review the point list, finding this under the Measure Monitoring option. You'll see the target height, the azimuth, and the horizontal distance for the reference target. Under the edit option, we can change various information for each of those targets, such as the working mode. So we can choose between manual, auto lock, fine lock, and long range fine lock. Manual is useful for direct reflex measurements or situations where you don't have a prism. Auto lock is useful for a generic manual measurement mode, is useful for GR measurements where you don't have a prism. Auto lock is the most common and prism lock mode for standard conditions. Fine lock uses a narrower field of view to lock onto prisms, such as for tunnel convergence monitoring or rail monitoring, where you have narrower line of sight between prisms. And then the long range fine lock is useful for targets that are over 700 meters, such as in open pit mine environments and dam monitoring. We can also add new points from this screen, whether that's from the existing list of points, keying in, or measuring new ones. When adding points, we can also leverage the Trimble Vision imagery and real-time video screen to add those targets. In this case, we'll add a DR-based target using the video screen. Once we have all of our monitoring targets, we'll press Next in the point list screen to proceed. In the epoch list screen, we can define how many monitoring epochs will be collected. We can choose from 1 to 10, or we can choose perpetual, which will continue to measure until we tell the software to stop. Under the options menu, we can find a variety of things to change how the monitoring will be performed, such as the epoch start time. We can choose from idle time, which is the time between epochs that the total station will wait until continuing a measurement. We can choose the interval time, which is the total time for each epoch. We can also choose how to define the number of measurements and rounds in an epoch. Each epoch is made up a number of rounds, and those rounds are made up a number of measurements, such as measurement sets. So in the case of where I'm taking a phase 1 and phase 2 measurement, that is considered one measurement, and I can have multiple of those in each round, and I can have multiple rounds inside one epoch for each monitoring point. There are a variety of other settings for changing how the monitoring will be performed, such as the adjust EDM settings for distance, which will change based on the measured distance and EDM type. There's also the auto measure passive targets, such as DR measurements, where it will automatically measure the target. And as well, we can enable the laser pointer to be turned on while making epoch measurements. The other options are setting the instrument mode automatically based on distance. So this will choose the best measurement mode based on the target distance. And as well, setting the skip obstructed foresights will automatically skip any monitoring points which are not able to be measured. This is useful in case there's obstructions. The compare with setting is useful for determining how the displacements are calculated, whether that's to the reference position and or to the latest measurement. Displacement tolerances and backsite residuals can be set both from a horizontal and vertical perspective as well. Once we're finished here, we'll press Enter to return to the epoch list. Now press Next to begin the monitoring process. The monitoring will begin instantly, and on the right-hand side of the screen, we can see the current status of the current epoch, round, and measurement, and a percentage overall in the entire monitoring scheme. In this case, we're starting the first measurement, and we're seeing the first measurement of 5 epochs and the first round measurement out of 3. Now we can change this list view in real time to see different information, such as the station site, station setup info, displacements, and any current movement warnings, all in real time as the total station is collecting data. The list view will show the current phase 1, phase 2 measurements and what has been already made during the current epoch. And we can see these measurements update in real time. Under the deltas menu, we can see displacements to the reference or the previous epoch in real time, and these update as measurements are collected. When a measurement is failed, such as if there's an obstruction in front of the target, we have several options to choose from. We can press continue to skip the measurement and move to the next one. We can use the retry option to attempt to remeasure the same target, and we can also use the select the aim to target option to manually aim the instrument instead of automatically. We can use the edit option to change any of the target information, such as the prism type, or we can import the entire monitoring operation and return to the main menu. In this example, we'll skip this measurement, and then in the list view, we can see it's defined by an X symbol as skipped during this epoch. The current monitoring measurement can be paused at any time. This is useful for changing the target information or the atmospheric measurements such as temperature and pressure. Once all the monitoring epochs have been measured, a review screen shows all of the displacements and an overview of how many measurements were made. The display can be changed to show different data types for this screen, and an additional epoch can be selected to continue measuring more monitoring data. At any time, we can view the displacement data in the current job by going to Reports and Displacements and selecting the displacement information. The previous and next buttons can be used to navigate through each epoch, or we can choose to measure additional epochs for another set of measurements. A variety of infield reports can be generated in Trimble Access, such as an epoch reference compare report showing all measured epochs and displacements, a single point displacement report, as well as a Microsoft Word format report showing scatter plots and displacement graphs for each monitoring point. Data from Trimble Access can be imported into Trimble Business Center simply by dragging and dropping the JXL or job file from Trimble Access Monitoring into TBC. And from here, we can do additional survey QC, or we can generate monitoring displacement reports and point charts in Trimble Business Center. This concludes a demonstration on Trimble Access Monitoring.